one?
Lights, camera, fraction! Oh yeah.
Okay, good. Very nice. Thank you. All right. So we're going to talk about. We're going to eventually talk about three-step equations, solving three steps. But before we do that, we first have to talk about like terms. I really haven't had a chance to really talk about what like terms are. If I said add 4 plus 3, are those like terms?
Yeah.
Those are totally like. Why are they like terms?
Because they have the same variable and exponent.
They have the same variable and exponent. Correct. What's the variable in this?
1, x equals 1.
What?
Nothing. Nada.
What he said is actually really true. I wasn't planning on doing this. So this is interesting. X to the 0 power is 1. So technically this is 4x to the 0. You don't have to necessarily write this down, but plus 3x to the 0. But 4 times 1 is 4, plus 3 times 1 is 3, which is 7. So that's a very long way to explain 4 plus 3, right? But in essence, yes, these are like terms because they either don't have a variable, or they have a variable that's x to the 0 power. Does that make sense? Okay? But what if I gave you something like this? What if I gave you 4x plus 5x?
They're still like terms, so you can just add them and make it 9.
So they're still like terms, yeah. So let's just remember, what does 4x mean? It means this: x plus x plus x plus x. That's what that means, right? So it means there are 4 x's. That's what it means, 4 x's. 4 apples, 4 x's, whatever. And this is 5 x's plus 1, 2, 3, 4, 5. So I'm adding 4 x's plus 5 x's is 9 x's, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you have like terms, you can take the coefficients, right? The coefficients in front of the variable, and you can add those, and then follow it with the x, right? So all I really have to do is go 4 plus 5 is 9x versus all of this, right? I don't really want to spend my time writing it the long way. Thank God for algebra. Algebra is all about shortcuts, right? So this allows us to shorten what could be a very, 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 very long equation, right? So especially if I had 463x plus 5,423x. I would not want to write those all out, right? I'd rather just add my coefficients, right? Now, what if I gave you something like this? 2x plus 3x plus 5x. What could I do? Rosemary?
They still all are like terms.
They're all like terms.
Add it up.
They're all like terms. So I can add the coefficients. I can add 2 plus 3 is 5, plus 5 is 10, so that equals 10x. Okay. Now what if I gave you this? 4x minus 7x. Hey, yeah, Jan.
So it's the same, like, you could just think of it as being 4 minus 7, and it would be, since they're both two different opposite signs, you subtract. So you do 7 minus 4 and keep the sign of the blah 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 blah, and then
Right.
7, so it's -3.
Negative 3x, right? So you're using those same rules that we talked about, you know, in the early days, right? When we were talking about adding and subtracting positive and negative numbers, right? What if I gave you this? 3x plus 4y.
You can
No.
I can't. I just have to rewrite it. That's
Yeah.
all I can do. I can't do anything else. Because they're not like terms, I cannot add the coefficients, right? Makes sense, right? It's like saying I have 4 apples plus,
And
I mean,
six
3
pears.
apples plus 4
Pears.
oranges. And then somebody asked me, well, how many oranges do you have? Well, I can't say I have 7 oranges, right? I have 4 oranges. You know, how many apples do I have? I have 3 apples, right? I could say, we could change it. Well, how many fruit do you have? Then I could say I have 7 fruit, right? Because then X is a fruit and Y is a fruit, but whatever. But you can't really do much. Okay, what if I did this though? What if I gave you 2x minus 6y plus 3x minus 2y?
Oh.
What could I do? Sienna.
You could add the 2 and the 3.
Yeah, so you're looking for like terms. These two are like terms. Notice I'm circling also the plus sign,
Is this positive?
and it's positive, so it's 2x plus 3x, so that equals 5x, right?
You could also add the 2y.
And then you do negative 6y.
Ah, and then
minus 2.
Negative 6y and negative 2y, that's negative 8y, right?
Yeah.
All right, awesome.
Yeah.
Okay, can I erase this?
No.
Yeah.
Well, I'm going to erase the first 3 and start up higher so I don't have to bend down. All right, what if I gave you this? What if I gave you this? 5x squared plus 3x squared plus 4x. Lucas.
Could you add the x's squared but not the
Correct.
singular x?
These two are like terms. This one is not. Remember what this means.
You can always put a 1 above it.
What?
You can always put a 1 above it.
You can always put a 1 above it, but that tells you that they're not the same terms, right? They're not like terms. Because this is, what this says right here is this. It says 5x times x plus 3x times x plus 4x. Do you see how they're different?
Yeah, but you could still put them together.
You,
Yeah.
not when you're adding. When you're multiplying you can, but when you're adding you can't, right? They have to, this says I have 5x squareds, right? This says I have 3x squareds. This says I have 4 only of an x, right? So I can't put them together if I'm adding or subtracting. Only if I'm multiplying or dividing can I combine. So my answer to this would be I can add the coefficients of the x squareds. That's 5 plus 3 is 8. So it'd be 8x squared plus 4x. Okay, does that make sense? Is it clear? Okay. All right, what if I gave you this? If I gave you 6x to the 4th plus 21 minus 2x to the 4th minus 14. Gardner.
So you'd put the 6 and the 2 together, so it'd be positive 6x to the 4th minus 2x to the 4th, and that would be 4x to the 4th.
4x to the 4th.
And then you do positive 21 minus 14, which I'm pretty sure is 7.
Yes, plus 7, right? Good job. Right? Pretty straightforward. Fist to 5. You guys feel like you get this? Awesome. Fist to 5. Yeah. Okay, great. All right. So that's like terms. So you're going to see like terms all the time in problems, okay? And we'll be doing more next week. But just so you know, there's going to be a quiz on Monday, okay? But the homework, it's going to be basically on the kind of stuff that the homework is about, okay? The homework involves the new part of 3 steps. Okay, guys, but listen, guys. Shh, 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 shh. Guys. The homework involves practicing some of the 3 steps, but also reviewing some of the stuff we've done. PEMDAS, evaluating when X and this is, Y is that. 1-step, 2-step equation, things like that. Yes.
Will the quiz be timed?
Will the quiz be timed? No. I don't believe in time quizzes. I don't believe in time quizzes. Yes, there are times when you have to go fast, but I think I've told you this before, right? Like if you're,
No, like you have to do it quick.
yeah, but it won't, no. We'll just It's not gonna be a really long quiz, it's just gonna be, I just really care to see, I just wanna be sure that we're all together. And you guys know how to do it. If you can do the homework and ace the homework, you're gonna have no trouble on my quiz, okay? It's not gonna be a real hard quiz. Alright, so now we're gonna talk about three-step equations. And in three-step equations, we're gonna add a little bit to the equation. So let's say I gave you, so for the first one, three-step equation. Okay, first one. Let's say I have 2x plus 3x minus 4x equal plus 2 equals 10. What would I do? Yes, Rosemary.
You could combine the 2x and the 3x and the 4x, and that would be 1x, and then
So 2 plus 3 is 5, minus 4 is 1x. Okay, we've got x plus 2 equals 10. You guys agree?
yeah,
Okay, now what?
8. X equals 8. You subtract 2
From each side, yeah.
Subtract 2 from both sides,
of 8,
and then I got x is equal to 8, right? That was only a two-step, wasn't it?
Right.
yeah.
Oops. Okay,
No,
All right.
I will now.
all right, well, I'll make it a three-step now. Okay, so how about this one? How about 6x minus, or how about plus, not 6, plus 8 maybe, minus 3x equals 13. 13, okay. Okay, that's fine, Jan.
So what I would do is I would do 6x minus 3x first,
Okay,
and you would have 3x plus 8,
3x plus 8, that's our first step, is equal to 13.
and then you subtract 8 from
Subtract
both
8
sides,
from both sides,
and then you have 3x equals 5,
okay,
and then you divide 3 by 3 and 5 by 3.
okay. And you're gonna have x is equal to 5 thirds. If you wanna convert it to a mixed number, you can. But it's also okay, in algebra, a lot of times, a fraction is more useful than a mixed number. Not always, but you gotta make sure you know how to do both. So let's just say we're gonna go ahead and also convert it. So 1 and what? 2/3,
Yeah.
right? 1 and 2/3. You guys all know how to convert fractions, right? Yes.
Can you explain it again?
This one?
Yeah.
So we're looking at like terms. We have 6 x's, and then we're taking 3 of them away. Does that make sense? So 6 x's minus 3 x's is actually 3x. 3 x's, right? Does that make sense?
Yeah.
And then plus 8 equals 13. Now we're subtracting 8 from both sides. You get 3x equals 5. A lot of times when I give you problems, they work out. You know what I mean? They work out with whole numbers, but not always. So I've got to sometimes give you some that don't, so that you get used to that fractions are okay. But when you do get a fraction, pretty typically in math class, unless you have a teacher that only gives you fraction answers, right? If you get a fraction, it should be sort of a red flag. Did I go back and just review what I did and make sure I did it right? Because it's very possible you made a little mistake with your minus sign or something, you know what I'm saying? But anyways, so yeah, it's totally fine to have a fraction. X is equal to 5/3 or 1 and 2/3, okay? What if I gave you something like this? 2, 3. If I gave you this, 2x parenthesis x plus 5 is equal to 30. Okay, Jan.
So you do distributive property
You guys remember that?
Yes.
because you can't simplify
And I really recommend you put your arcs so that you don't forget to multiply the 5, right? Because that's the typical thing. So often people say 2x plus 5 is equal to 30 instead of 2x plus 10 is equal to. So go ahead, Jan. So
and then you get 2x plus 10, and you subtract 10 from both sides. And then you have 2x equals 20. And then you can do it in your head, or you could do divide by 2, divide by 2, and then you get x equals
Yes. Okay, makes sense? Pretty straightforward, right? Pretty easy. Okay, what if I gave you this? -3 2x squared minus 4, not x squared, sorry, 2x minus 4 equals, what is this going to give me? Let's do that. All right, somebody different.
Bang.
Lucas.
So you would use the distributive property and multiply 3x by 2x and 3x by, negative 3 by 2x and negative 3 by 4.
Okay, what did I get here?
And so you would get negative 6x, and then you would get just
Plus
regular
12
Yeah.
equals 24. Now what?
Now you would subtract 12 from each side.
Subtract 12. Minus 6x is equal to 12.
And then you would divide each side by 6. So
Are you sure?
divide each side by negative 6.
Negative 6, right? Whatever's in front of the x is what you want to divide by, even if it's negative. Because otherwise, if I did this, I would get negative x is equal to 2. Which is fine, because then, but I'd have to keep going. Do you follow me? I'd have to keep going. I'd have to do another step. I'd have to multiply by -1, multiply by -1, and then I get x is equal to -2. But if I had just done this, it would have immediately been x is equal to -2. Do you see that? You guys see what I'm doing? Make sense? Okay. All right. And then there's the last one I'm going to show. I did not put on the homework on purpose, just because I don't want to overwhelm you guys, because you're going to study for a quiz too for the weekend. But this is not hard, you'll see. Now, I think you guys will have no trouble with it. But what if I gave you this? 4 times 2x minus 5. Let me think here. Minus 4x is equal to 16. What would I do? Luke.
Would you use like terms or distribute?
What would I do first? I would have to do distribute. You've got to get rid of parentheses before you can deal with like terms. Because notice, these like terms here, even though those are like terms, this is busy being multiplied by 4. Do you see that? See that? So you can't deal with this until you get rid of the parentheses.
4 times 2 x times 5 20, and then 2 minus 4 equals 16.
Okay.
Would you do plus with 4 or plus 20? You do 8x.
What are my like terms? I've got 8 x's and I've got minus 4 x's, right?
So that would be 4.
4x. So that gives me 4x minus 20 is equal to 16.
Then you do plus 20.
Plus 20. Plus 20. That gives me 4x,
Equals 30.
36.
And then what if you divide by 4?
Divide by 4.
And then x is equal to 9.
Yeah, beautiful. Nice. Nice job. Nice job. Yeah, crazy, right? So I didn't put these like one like this one on the homework. I had them originally and I took it off.
Really?
But they'll be like 1 through 4, right? On the lecture. But next week you'll start getting stuff like this and maybe even a wee bit more complicated. Notice on all of the ones so far, all your variables. You guys listening, Logan? On so far that everything I've been giving you, all the variables are on the left side of the equation, right?
Oh no.
Next week, we'll start putting variables on both sides. And then we got to figure out how to solve for those, how to work with those, okay? And it's not hard, it's just more steps. But this is, you see how we started with the one-step equations, and then we moved into the two-step, and it gets more and more complicated. So it's great to have a process, right? Remember when we were talking about the easy ones, we already knew the answer, but I made you do the process, because the process is really important when they start getting harder, right? More complicated. So anyways, that's it. So I'm going to end the lecture, and didn't quite work.